Alright, so as I was doing this, this just says equivalent fractions, and you make equivalent fractions just by multiplying the numerator and the denominator by the same number, or dividing the numerator and the denominator by the same number. I could also say that all I'm doing is I'm multiplying the fraction or dividing the fraction by a different form of 1. So equivalent fractions represent the same thing, or they have the same amount shaded in. It's just naming it something different. What do I mean by a different form of 1? Well, if I have a fraction 4 over 4, that's equal to 1. If I have something like 8 over 8, that's equal to 1. If I have something like 3 over 3, that's equal to 1. When the numerator and the denominator are the same, those are all equal to 1. So then what I'm doing is I'm multiplying what I have by a version of 1, or dividing what I have by a version of 1 to get an equivalent fraction. Here is an example of getting an equivalent fraction. So you take something like 5/8, and if I multiply it by 3 over 3, which is equal to 1, then that's going to equal 15 over 24. And 15 over 24 is equivalent to 5/8, and 3 over 3 was equal to 1. So I multiplied 5/8 by 1 to get 15 over 24. So I'm just making it so it's equivalent. These are all examples of the multiplicative identity property, which says that if I multiply something by 1, I'm going to get the same thing. And in this case, 15 over 24 is the same thing as 5 over 8. And this one's going to be very similar. So right here, instead of multiplying the numerator and denominator by the same number, I'm going to divide the numerator and the denominator by the same number. So we have 15 over 24. So to get an equivalent fraction, I'm going to divide 3 over 3. 3 over 3 is equal to 1. And if I divide 15 by 3, I get 5. If I divide 24 by 3, I get 8. So 15 over 24 is equivalent to 5 over 8. And I did that by dividing it by 1, which would be similar to the multiplicative identity property. The second main thing from this section that I want you to make sure you understand is making sure we can put a fraction into simplest form. Simplest form is where the only way we can multiply, or I'm sorry, the simplest form is where we can only divide the numerator and denominator by 1. That's when a fraction is in simplest form. So in way 1, I'm just going to divide it by common factors, factors that I know for 24 and for 36. So I know that those are both even, so I can divide them both by 2 over 2, which is equal to 1. And then when I divide them both by 2, I get 12 over 18. Those are both even, so I know I can divide them by a common factor of 2. And 2 over 2 is equal to 1. So I'm going to get 6 over 9. So that's equivalent to 24 over 36. Now 6 over 9, I know they're both not even. However, I know I can divide them both by 3. And this is where this method becomes tricky, because sometimes you don't see what you can divide them both by. So I get 2 over 3. Now 2 over 3, the only number I can divide both the numerator and denominator by are 1. So that is in simplest form. Now this is simplest form, and this is the way number 2. A fraction is in simplest form when the only number that can evenly divide the numerator and the denominator is 1. So for this example right here, in way number 2, instead of just dividing it by common factors of the numerator and denominator, I'm going to find the greatest common factor, the GCF. All right, and in order to find the GCF, there's 2 ways that we've gone through for dividing the GCF. And the first way is listing all the factors. So I'm going to just list all of the factors, and we're going to use 24 over 36. And I'm going to list all the factors for 24 and for 36. All right, and sorry if my writing isn't perfect here, but for 24 I have 1, 2, 3, 4, 6, 12, 8, 12, and 24. For 36, my factors are 1, 2, 3, 4, 6, 9, 12, 18, and 36. Well, the biggest one there, the greatest factor that they both have in common, is going to be 12. So I'm just going to divide the numerator and the denominator by 12. And so now I get the fraction that is 2 over 3. 2 over 3 is in simplest form because the only number that can divide them both evenly is 1. Simplest form, way number 3. So to get a fraction in simplest form, the only number that can divide the numerator and denominator evenly is 1. That's how I know a fraction is in simplest form. I like this way the best. For this one, we take 24 over 36. Then what I'm going to do is I'm going to do the prime factorization for 24 and for 36. I'm going to do that by making a factor tree. So for 24, I know it breaks down to being 6 times 4. And then I know that I can break 6 up into 3 times 2. And I know I could break up 4 into being 2 times 2. For 36, I get 6 times 6. And I know I can break down the 6's as being 3 times 2 and being 3 times 2. Now what I'm going to do is I'm going to write those as being equivalent. So I'm going to say 24 equals 3 times 2 times 2 times 2. And 36 equals 3 times 2 times 3 times 2. Then all I'm going to do is I'm going to cross off the ones that are the same in the numerator and in the denominator. So as I look at this, I see that both the numerator and the denominator have a 3. That's a 3. So I'm going to cross off the 2 3's. Then I know that both the numerator and denominator have a 2, so I cross off the 2. I also see that there is a 2 down there and a 2 up there. Now what I'm left with is the equivalent fraction of 2 over 3. And I know that's in simplest form because the only number that can divide the numerator and denominator evenly is 1.